How are you doing? It's me, the pioneer in methods, the research in the field of mathematics. Today we told that at 8 o'clock exactly I will be live, but I was online with my students. So that's why now I'm go back to explain how can you solve 2 to the power 4 using the extension. Means you will start with 2 to the power 4 and you will come to an extension, okay, so that you can solve this polynomial equation. Okay, now I'm going to learn this to use, of course, to use my laptop to explain this. Okay, I wish that everyone is now joining the lecture. It's very important for you, for those who are smart in their minds, and for those who wants to navigate in the sea of mathematics. Okay, so we start learning. We call that this is open to the power 4. We calculate S1 learners is going to be equal to 10, S2 is equal to 40, and S3 is equal to negative 50. Therefore, after, let's say, finding my S subscript k minus 1, where k belongs from minus 1 to 3, I should write the polynomial as that. So therefore, p of x is equal to x raised to the power 4 minus a 0 for the q x cubed plus s1 of 42 times x squared minus s2 of 42 x raised to the power 1 plus s3 of 42 equal 0. After substituting, I will make x raised to the power 4 plus 10x squared minus 40 times x minus 51 equals 0. Therefore, learners, the roots of these fourth degree polynomial equations are obtained when finding the value of sk minus 1 over r using the discrete formula of Mr. Sultan Ezouidi. We note that yk or y subscript k from 0 to 3 are called the roots of this polynomial to the power 4. Okay, this one. So I will make yes this one. Therefore, x we call y equal negative and 0 for the q, which is equal in fact to 5, okay, plus 4 times xk from 0 to 1 to 3, all divided by 5. This xk learners, okay, comes from the fifth degree polynomial equation when you make extension. Okay, I'll change this color around. It will look like that. So negative at 0 for 2 plus 4 times learners xk from 0 to 3 is 5 exponential 2k plus 1 I. Pi divided by 4, all divided by 5. Because this x roots comes from a fifth degree polynomial equation when you make extension. So this one I will just write minus 5 plus 4 times 5 is 20 times exponential 2k plus 1 between parentheses times I pi divided by 2, all divided by 5. Therefore, 5 is called common factor. I will simplify by 5 in the numerator and 5 in the denominator. I will obtain y subscript k from 0 to 4 is negative 0 for the q plus 4 times xk from 0 to 1 over 5. So this one, of course, this is 1 to 3, 1 and 2 and 3, 2 and 3. Of course, has to come minus 1 because minus 5 divided by 5 minus 1. And 20 divided by 5 is 4 exponential 2k plus 1 times pi over 2. Therefore, this is, it's called x roots of these polynomial to the power for this one, of this one learners. Okay, this is the roots of it. Okay, I'll change using the color as possible, or red, or yellow. Okay, now, in order to solve our fourth degree polynomial equation, our fourth, our original fourth degree polynomial equation, I'm going to write beta subscript k from 0 to 3 is L0 for the q plus yk from 0 to 4 divided by 4 because I'm working with 2 to the power 4. So it will be 5 because L0 is 5 plus, you see this is yk you calculated is minus 1 plus this one, or exponential to k plus 1 I pi over 2. Therefore, you can see 5 plus negative 1 will give you 4. 4 divided by 4 is 1. Plus 4 divided by 4 is here, is 1. And cancel that will be exponential to k plus 1 pi over 4. Now, I will go to explain this for you. Okay, I will go to explain this for you, learners. Yes, it works. Okay, I already shared the screen. Okay, I'll come with that. Now I'm going to extend, means we solve this polynomial to the power 4 by extension. By extension. Okay. So, means what by extension? Means that you are going to write your fourth degree polynomial equation and you multiply by s. Then you will calculate s minus 1, s0, s1, s2, s3, and s4. Then, after that, you will obtain what will be given after. So, we can see this one, in fact, is 2 to the power 5. Okay, because the highest power is 5. And p of x has to be equal to x raised to the power 5 minus l0 over 2 raised to the power minus l0 over 2 multiplied by x raised to the power 4 plus l1 over 2 times x squared minus L2 for the 2 x squared plus L3 for the 2 times x minus L4 for the 2 equal 0. Let's focus on this polynomial to the power 5. To find out the roots learned of this polynomial, we should determine the values of SR for the Q, okay, relative to LR, let's say, relative to LR, okay, okay, relative learners to LR of ODQ, where R belongs to minus 1, 0, 1, 2, 3, and 4 because the highest power is 5, so n minus 1 will be 4. Now the coefficient of my second original fifth degree equation is that 5, 10, 10, 4, and L4 is going to be 0. So I will use this formula of Mr. Sultan that had been generalized more than 14 years. S subscript k minus 1 for the I, the sum from 0 to k. K now is going to be 0, after that will be 1, after 2 and 3, 4. Okay, then combination n minus r choose k minus r, n is to the power r between parentheses because 0 for 2 raised to the power k minus r times n r in 24. Now setting k to 0, so the formula has to be written as s minus 1 for the r by convention is going to be equal to 1 simply because the combination are just like here, simply because learners, simply because this one has to be equal, okay, combination equals combination. This is of course is n because I'm working with the putting to the power n. Okay, after that n is going to be 2. Okay, this is combination. So n choose minus 1 plus 1. Okay. Minus 1 plus 1, which is equal to, in fact, to combination and choose and choose and choose 0, which is going to be 2. Okay. Now we move to S0. S0 learns by convention with the sum of matrix when, let's say, when x equal, when k equal 1, I will obtain a 0 is going to be equal to 0. Therefore, now a 0 for the r is negative combination plus 3.5, which is negative 25 plus 5 times 6 out will be 25. So the sum of this 2 is going to be equal to 0. Now I'm going to use the scheme from the author of the inventor, Mr. Murad Sultan Ezouidi, and we'll get as 1 over the r equal minus 1 minus combination 1 to 1 times combination into 2 times a 0 for the q squared plus n squared times q1. Now I will substitute. So this one is going to be negative combination 1 to 1 times combination 5 to 2 times 5 squared plus learners what is 3 plus uh, plus 5 squared times 7. This one you can use a calculator. It's going to be equal to 0. Okay. Now I will proceed. I should find now S2. To find S2 learners, you just put k equal 3 in this formula. So it will be S2 equal exactly 2 times combination n to 3 and denotes the highest power of my fifth degree from the equation times n0 for the 2 raised to the power 3 minus combination n minus 2 choose 1 times n squared times n0 for the 2 times n1 plus n cubic times n2 for the 2. Therefore, you can see that L0 is 5, L1 is 10, L2 is 10, and L3 is 20, and L4 is going to be 0. You just make substitution values, okay? And use the calculator, you will figure out that the value of S2 is going to be equal to, in fact, 2 and L, okay? Now I'm looking for finding k equal 4, okay? We will use the discrete formula of Mr. Murad, okay? Sultan Ezouidi, HSM, okay? HSM is really HSM, the pioneers in method, the Tunisian researcher, HSM, okay? I'll just extend this so that like that. So I will develop or make expansion for this discrete formula. I will obtain the last generalized formula when k equals 4 for any individual formula equation, not only when the highest power is 3 or 2 or 4 or 5 or 6. So whatsoever your polynomial, okay, this will work. Okay. Now I will just focus on the most one, which will be negative 3 times combination n plus 4, and n is 5 times a 0 for the duration of 4 times combination n minus 2, choose 2, okay, and square times a 0 for the 2 squared times L1 minus combination n minus 2 n minus 2 is 1 times n cubed of 0 for the 2 times learners n2 for the 2 plus n raised to the power 4 times n3 for the 2. After making your calculation, you will obtain the S3 factor equal to negative 625. This is the value of S3. Everyone review at least of scientific calculator and do his or her best to evaluate the impact S3 is going to be negative 625 using the generalized formula S3 when k equals 4 in the discrete formula of Mr. Murad Sultan Ezouidi. Now, learners, we reach now the last coefficient, okay? I am going to put k equal 5 in the discrete formula, okay? S4 has to be equal to 4 choose 1 and choose 5 and 0 for the 0 to the power 5 minus combination n minus 2 choose 3 times n squared times the cube of a0 for the 2 times n1 plus combination n minus 3 choose 2 times the cube of n times the square of n0 for the 2 times n0 for the 3 minus combination n minus 5 choose 1 times n raised to the power 4 times n0 for the 2 raised to the power 1 times n3 for the 2 plus n raised to the power 5 times n3 of 42. So this one after calculation, learners, you have to set that to be equal to 0. Now we will make our conclusion. So this is our original polynomial. When we extend for the polynomial equation, now I will write the new coefficient of this polynomial equation that has to be written as x squared x raised to the power 5 minus 0 for the 2, which is equal to 0, x raised to the power 4. Okay, plus S1 of 42 x raised to the power 3, S1 is going to be 0 here, minus S2 42 also going to be 0, times x squared plus S3 42 which is different to 0, minus S4 for the 2 calculate here will be 0. Therefore, I will make x as a common factor. X is going to be equal to 0. This is x equal to 0 means that okay, or x raised to the power 4 equal negative S3 42 exponential 2ik pi. Okay, the S3 in fact is negative to 625. Okay, so when transfer on the right hand side will be positive, will be 625 exponential 2ik pi. Therefore, this is x raised to the power 4. Now x subscript k from 0 to 3 is the fourth root of 625 exponential 2 k pi. Okay, so the fourth root of 625 is 5. Okay, and the fourth root of exponential 2ik pi is exponential 8 pi divided by 2. Now, I will go to we find now the x roots of this new fifth degree polynomial equation when making extension. So I will just write beta k subscript from 0 to 1, 3 is L0 of O dq plus 5 times this divided by 5. The L0 of O dq is 5. Let's see, this one is 5 plus 5 exponential 8k pi over 2 over 5 will be 1 plus exponential 8k pi over 2. Therefore, for beta k subscript 0, I will obtain immediately 0 because I extend my polynomial. That's clear that x equal 0 is going to be the first 0. And, okay, it will be 5 minus 5 divided by 5 is going to be equal to 0. Okay. 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 Thank you for listening. This is Mr. Murad Ezouidi. Okay. I will just now try to do that. Okay. Thank you for listening, learners. I'll just make sense for you. Okay, this is Mr. Murad Ezouidi, the pioneers in methods. I try to speak to you. Okay, and see you next time. Always, I will let you learn things, new things, okay, and new theories, especially for nth degree polynomial equation and nth linear equation. Okay, thank you for that. And see you. This is Mr. Murad Ezouidi, the pioneers in methods, is here to help you. Okay, okay, is here to help you to solve not only third degree polynomial equation, not only fifth degree polynomial equation, not only eighth degree polynomial equation. Also, we will solve together 9 degree polynomial equation, and we will solve also 10 degree polynomial equation. We will solve 11 degree polynomial equation, and also we will solve 12 degree polynomial equation and 13 degree polynomial equation, and we will solve 14th linear, 13th degree linear equation. And there is, let's say, in fact, strong relationship between nth degree linear equation and nth degree polynomial equation. In fact, it's going to be the same, but there is a relationship between them, which is very important and very, very extraordinary while thinking of it, okay? And while thinking of the roots of this kind of nth degree linear equation and the roots of nth degree polynomial equation. Okay, thank you for listening. We hope so that you got the point. How can you solve such a polynomial to the power 5 using the discrete formula of Mr. Murad Ezouidi? And this discrete formula, learners and professor and colleagues, okay, is going to be new. Okay, and thanks for joining you in the lecture, and I wish that you got the point to solve such kind of questions. Okay, and thank you for listening, and goodbye. Let's first of all focus on okay, yeah, it's enough. Okay, thank you.